Hi, greetings to everyone. This is Lata B, and my batch members are A. Sujita and S. Hemalata. We are the students from Tech Multitech Dr. Rangarajan, Dr. Sakuntala Engineering College. We are from the Department of Biomedical Engineering. We did a project in the field of biomaterials, and the title is an in vitro evaluation of bioactive glass with polymer scaffold for bone mineralization. Our aim is to Our aim is to synthesize the porous bioactive glass by microwave assisted method and to fabricate the scaffold for bone mineralization applications. Bone mineralization is nothing but laying down of minerals on the bone matrix. Bone replacements are frequently needed in many orthopedic and maxillofacial surgeries. For a long time, both autografts and allografts have been considered the best treatments for bone substitution since they provide a very fast osteointegration with surrounding tissues after implantation. They present several disadvantages also. As far as allografts are concerned, there are still several issues about the possible immune rejection or disease transmission from the donor. On the other hand, autografts are penalized by blood loss and donor site morbidity, which is a direct consequence of the explanation. For these reasons, artificial grafts called scaffolds are challenging candidates for supporting the newly formed bone tissues. Scaffolds are the main ingredients for the tissue engineering. The scaffold should be porous so that having the property of osteoconductivity. Both natural and synthetic biopolymers are employed to realize these scaffolds for bone tissue repair. We are using polyurethane polymer. Bioactive glass is a ceramic biomaterial that consists of an amorphous silica network with the calcium oxide and a phosphate group attached. Bioactive glasses are not like a conventional glass to tear our tissues. It is a glass which is having proportion of calcium and phosphate similar to our human bone. They are actively interact with the biological environment and form the hydroxyapatite layer. Although autographs and allografts, as I said before, autographs are having a disadvantages such as disease transmission from the donor. For these reasons, scaffolds acts as a substratum to ensure cell attachment, proliferation, and differentiation are used. Mineralization of bone is essential for its hardness and strength. It involves the formation of crystals of calcium phosphate by bone forming cells or scaffolding. In this work, we prepared bioactive glass powder by microwave assisted method. Various methods are available, such as metal quenching, salt gel methods are available. But this is we chose this method for quick operation. It's a one-day process of preparation of bioactive glass powder. Polyurethane polymer is blended with the bioactive glass powder and formed as a scaffold. Biocompatibility test of the synthesized material will be carried out by in vitro investigation by apatite formation behavior when immersing the bioactive glass in the simulated body fluid. Polymer scaffold can add the property of the mechanical strength, interconnected porosity, and surface area to direct tissue regeneration. The surface morphology will be examined by scanning electron microscopy. Bioactive glasses are a class of unique synthetic materials that react in the presence of body fluids. As I said, bioactive glasses having the same proportion of calcium and phosphate, which are present in the proportion that is similar to the bone hydroxyapatite. They are highly biocompatible. Okay. Our first process is the synthesis of bioactive glass powder. Synthesis of bioactive glass powder by microwave assisted method. For that synthesis, we are in need of the raw materials such as calcium nitrate tetrahydrate for the calcium source and diammonium hydrogen phosphate for phosphate source and sodium silicate solution for the silicon source. For synthesis, the precursors were dissolved in a deionized water and transferred to the ultrasonic bath. Ultrasonication process was carried out at 70 degrees Celsius for 4 hours. And then the prepared powder was filtered using a Watchman filter paper, and the remaining output was kept under the microwave operation in the second batch of powders. Um, the obtained amorphous powders was washed in a deionized water and then filtered. After drying for 24 hours in a oven at 80 degrees Celsius, the powders was calcined at 700 degrees Celsius temperature for the development of glass. This is our workflow. and the chemicals were combined and kept under the ultrasonication process. Then it is washed and then filtered. Then it is kept under microwave operation for drying. Finally, it is calcined at 700 degrees Celsius. For in vitro biological tests, we are in need of a simulated body fluid. Simulated for body fluid is nothing but it resembles our blood, which having a pH of 7.4. These are the reagents needed for the preparation of simulated body fluid. For the preparation of simulated body fluid, we need 700 ml of distilled water was taken into a 1000 ml of beaker, and it is placed on a magnetic stirrer at 36 degrees Celsius. The reagents are dissolved one by one in order in 700 ml of the distilled water. Prepared SBF should be preserved in a plastic bottle with a lid put on a tightly on the kept at 5 to 10 degrees Celsius in the refrigerator. SBF shall be used within 30 days after preparation. The specimen will soak at SBF at 36.5 degrees Celsius for different periods. For the preparation of SBF, the first to seventh order reagents were mixed one by one. Um, the one should be dissolved, and after that, the other should be added. And the ninth and eighth order should be mixed with the other reagents. Um, After it is tested for the pH value of 7.4. Finally, the preparation of scaffold. In the polymer replication process, the starting structure is prepared by coating the polyurethane foam with bioactive glass particles by slurry infiltration. The bioactive glass was obtained by dispersing the glass powders into distilled water. The polyvinyl binder was added to control the slurry viscosity and to favor the adhesion of the glass particles to the sponge. Then the sponge blocks were manually immersed in the slurry for 30 seconds and accurately impregnated. The sponges were retrieved from the suspension, and unlike the traditional replication technique, they were not squeezed but kept fully loaded with the slurry. The samples were immediately dried using a air flux at 150 degrees Celsius for 20 minutes. This is the process of preparation of the scaffold. First, bioactive glass powders is mixed with a polyvinylic binder, and the polyurethane sponge is added to this. The polyurethane sponge is immersed in the slurry and at various intervals, and it is kept at air flux 50 degrees Celsius for 20 minutes. Then it is sintered and or lyophilized to get scaffolds. This is our final output. In this study, porous polymeric bioactive glass composite possessing an improved mechanical properties and osteointegrative potential has been described. To test its osteointegrity, and it is cultured for osteoblast cells. The polyurethane bioactive glass composite was developed for several purposes. First, our goal was to synthesize the bioactive glass powder. The BG powder was blended with the polyurethane polymer to improve its biocompatibility. The polyurethane bioactive glass was then immersed in the SPF to evaluate its biological response. Then the sample was examined under SEM. These are the SEM images we got. Then it is given for Fourier transform infrared microscopy. By this peak number, we are saying the presence of the reagents. Near absorption band 3467.38 centimeter, the calcium phosphate layer is present. These are the exotic spectra of bioactive glass. Our 14-day sample was given for XRD. Diffraction peak was observed at an angle of 30 degree to 40 degree corresponding to the hydroxyapatite phase. We are having the hydroxyapatite crystal peaks in the range of 30 degree. So, thank you.